Now we will see what happens when we replace the 0 with a 1 and the 1 with a 0. So here we are going to have a 1 in OR, and in AND we are going to have a 0. Okay, so what happens when we do 1 or x? What happens when we do 1 or x? What happens when we do 0 and x? Know the answer, but we'll just go through the motions. Okay, so we want to go from our home A to our office B. There is a path that is free, and there is x that is unknown. It might be free or might be known. Then we'll always take the path that is free. Will not depend on x, right? So we don't want to know the state of the variable x. Let it be unknown, that is not a problem. So if there is a choice that there is a free path and there is an unknown quantity x, another path whose state is unknown, then we'll take the path where the state is known and free. Okay, so 1 or x is equal to 1, and if we replace the order, that the left side path is x whose state is unknown, and the right side path is 1 whose state is free, that is also the same. We know that there is a path from A to B, so it is 1. So if there is a path from A to B, then the value is 1, and if we know for certain that there is no path from A to B, then it is a 0 for certain. Similarly here, you know that the first part of the road is blocked. Okay, so you cannot reach from A to B. As simple as that. You don't need to know the state of the path x. You don't need to know the state x of this path. You know that the path 1 is blocked, or even the opposite is blocked. Then you know the entire road from A to B is blocked. So when it is blocked, we signify it with a 0. So we are saying that the output is 0 because the path is blocked. Now we can reverse it and put x here and 0 here. That is the same thing, that the path from the first part is x, that is an unknown quantity. It might be free or it might be blocked, but the second part is blocked for sure, so there is no way to go from A to B. So whether it be 0 and x, or whether it be x and 0, the output is 0. That is, there is no path to go from A to B. If there is path to go from A to B, then the output is 1. If there is no path to go from A to B, the output is 0. Okay, clear? Now we'll go through another property of Boolean algebra. So what if we had 2x, right? What will be the output of x or x? What will be the output of x and x? So this is not a 1 anymore, this is also x. So there are two optional paths, both have the same state. Okay, so if one is free, the other is free. If one is open, the other is open. If one is free, the other is free. If one is blocked, the other is blocked. Both have the same states. So you just need to know the state of one of them. Because both have the same states, you just need to know the state of one of them. So if this one is free, this is also free, then the output is free. If this is blocked, then this is also blocked, then the output is blocked. If both the paths are free, then you can go. If both the paths are blocked, you cannot go. As simple as that. and here replacing the 0 with an x. If both the paths are free, then you can go from A to B. If both the paths are blocked, you cannot go, obviously. So here also knowing one of the values is sufficient, because we know that whatever the state up to this point, same will be state up to from this point to this point. Whatever the state of x, means whatever the state of the road from this point to this point, same is the state of the road from this point to this point. So if from this point to this point the road is blocked, then from this point to this point also the road is blocked. Ultimately the road is blocked, and you are knowing that from x itself. If from this point to this point the road is free, then from this point to this point also the road is free, and you know that from the state of x itself, so you don't need to know anything else. So whether you can go from the point A, your home, to your office B, depends on x only. So this will be known by the state of x. Whether you can go from your home to your office will depend only on the state of x. So you don't need to mention it twice. So mentioning it once is okay. Okay. There is another property. This is the inverse property. So what happens when we do x or x inverse? Here the NOT gate comes, okay. So whatever the value of x, x naught is the opposite of that. So if x means blocked, then x naught means free. And if x naught means free, if x means free, then x naught means blocked. Right? So you can see if x is free, x naught is blocked. If x is blocked, then x naught is free. So one of the paths is always free, and since OR represents the options, one of the paths is always free. So you know that you are always free to go from A to B. So the output is 1. Right? So this is a very simple one. If there is a path from A to B, means if x is free, then x naught is blocked. If x is blocked, x naught is free. There is always a path to go from A to B. So the output is 1. And similarly, the order does not matter here also. This could be x naught, this could be x, it does not matter. And in this one, one of them is x naught. So if x is free and x naught is blocked, can you go from A to B? You cannot go, because one of them is blocked. If x is blocked and x naught is free, then can you go from A to B? No, you cannot go, again it is blocked. So this is always blocked. Even if one of them is free, the other is blocked. So this path is always blocked. And again it does not matter, you can just replace this x with x naught and this x naught with x. It does not make a difference. So whenever one of the paths is free, another one is always blocked, and so you cannot go from A to B. And the outcome is that you cannot go from your home to your office. The outcome is a 0. And in this, you can always go from your home to your office. The outcome is always 1. Okay, clear?